Hello, this is Benjamin from Eclipse. Welcome back. We keep the regular schedule, right? We see each other every other week now, and we're very happy to have yet another cool virtual IoT meetup this week with Steve. Steve is a jack of all trades. He's a researcher and entrepreneur, and he does lots of research around the geospatial. Why are you laughing? You are a jack of all trades, and you're doing lots of great stuff around geospatial APIs for IoT. You're actually also a challenger in the Open IoT Challenge, and we were just chatting about that before going live. So, Steve, without further ado, why don't you maybe give us a more in-depth introduction of what you're doing, and yeah, tell us what OGC is all about and what kind of APIs people can use to do IoT and geospatial. And please make sure that if you have questions, guys, you can use the Q&A on Google Plus, or maybe better and more convenient would be using the virtual IoT hashtag on Twitter. We will be monitoring that and sending the questions Steve's way and answering them at the end of the presentation. So Steve, whenever you want.
Thank you very much, Benjamin, and thank you all for attending this webinar. Good morning, good afternoon, and good evening. I think you guys are from everywhere. So let me share my screen first. Okay, supposedly you can see my screen now. Great. Okay. Great. So today I'm going to talk about OGC, which is Open Geospatial Consortium SensorThings API, and it's a API for IoT data interoperability, and with a special focus on geospatial components there. And then agenda. So what I'm going to talk about first, in case you are not familiar with OGC, so talk a little bit about OGC and why location almost always matters, especially maybe in IoT. And what do we mean by IoT interoperability? It's a buzz term, interoperability in IoT, blah, blah, blah. But what do we mean by that? And what are the layers? And if we say something is truly interoperable, what do we mean by that? And then we talk about OGC Sensor Web Enablement, which is a suite of standards for sensors, connecting sensors into a web. And then we talk about part of this family, Sensor Web Enablement family, which is the latest standards called OGC SensorThings API. And I will talk about some details about SensorThings API and benefits, case studies, and finally demo and questions. So a little bit about me. I'm a professor, associate professor at geomatics engineering at the University of Calgary. I'm also leading some international standard work, including OGC and ITUT, it's a United Nations standard body, and focusing on IoT. And then I also have a startup company called Sensor Up. And so the idea is this: I very much focus on, I want to disrupt the silos of the IoT. And about Sensor Up, we consider ourselves as a world leader in OGC Sensor Web and IoT. For example, we developed the very first SWE, Sensor Web Enablement client, back in 2005. And our clients include Lockheed Martin, Natural Resources Canada, Agriculture Canada, so on and so forth. And we're leading some international effort. And then we developed the first SensorThings implementation. And we're a proud member of Eclipse and OGC. Okay. Go to details. So first, what is OGC, the Open Geospatial Consortium? It's a non-for-profit international consensus standard organization. It's a SDO. It's a recognized SDO, and especially its focus is geospatial standards. So it has this year is the 22nd year. We have more than 500 members, more than 40 standards. And if you are loading a map from the web, actually you are using OGC standards. And some OGC standards also become ISO standards. We'll talk more about that later. So what are OGC standardizing? So, you know, if we talk about standards, right, especially for IT standards, we have to talk about layers. So which layer is OGC standardizing? So basically there are two components. Most of the OGC standards fall into these two categories. So first one is information models and encodings. And that means, okay, when we talk about geographic feature, what do we mean by geographic feature? And then what are the encodings for the geographic feature, like GML, like KML? You might have heard of KML. That's from Keyhole and Google Earth. And also, this is the information model encodings. And the second part is, once we have the information models and encodings, and how can we exchange these information models and encodings? So that's the web service interfaces. And actually, this OGC standard is also ISO 19119. So basically, most of the OGC standards focus on these two. So in other words, OGC's IoT work or sensor web work can be considered as a web of things as well, because we are sitting at the top of the layer stack. Okay, so why location almost always matters? First of all, a thing exists in space and time. So let's say with an IoT device, and if you don't know the location, you don't know the time, and the data from that device is not very useful. I'll give you an example. For example, let's say we have a smart smoke detector, so it connects to the internet. And then if you don't know where are the smokes, and then the data is not very useful, yeah? However, there's the other question. Okay, the next step. Okay, let's say we have a smoke detector and we know there's smoke from remote. And what are we going to do? Of course, you want to do routing, right? You want to evacuate people. So how do you describe the location of a smoke detector if you want to do routing? Actually, it's a GIS question. So are you going to use latitude and longitude, like XY, to describe location for the smoke detectors so you can do evacuation? Actually, no. You need to know the topological relationship, so the connectivity of the locations. So for example, to do routing, geometry is not very important. You need connectivity, which is topology. And so for example, you can use your Dijkstra algorithm to do the routing, shortest path, for example. So this is an example that location actually need to be handled carefully in the world of IoT. Geometry, yes, most of cases use geometry, but in many cases, you not only need geometry, you also need topology. So it's called duality. So just to let you know, this is one example. Location is very important, and then to handle location information, you do need some careful thinking. And the other thing is, we look at the locations. We can see evolution of the location technology. So in the early days of GIS, 1980s, we can see the regional centric, right? So we have we focus on certain region, a state, a province, and then 1990s with a better location collection technology, so we can focus more on the feature centric, so buildings, for example. And with the the smartphone showing up, and cheap GPS receiver, and we switch our focus until we can deal with human-centric, so it's smaller area. And finally, right now for the IoT area, actually it's getting smaller and smaller. The spatial resolution is finer and finer, so it's device-centric. So if we use this graph to look at it, the y-axis is number of users, and the x-axis is the size of space. As we can see, so large size of space, like on your right, that's a region-centric. And then when you go further left and smaller, and then we're focusing more on the IoT space. And when we reach to IoT space, like human space, human-centric, the device-centric, and the number of users is increasing. And in many cases, on your left-hand side, actually, we can categorize them as the indoor space. And let's think about it. How many things are indoor? Lots of them, right? And actually, how do we describe indoor space? Interesting question. So we can say it needs to be handled carefully, right? A latitude, longitude, maybe it's not maybe, it's not useful for indoor space. In OGC, we have something called indoor GML. So that's the language information model encoding to describe indoor space, for example. And then for IoT space, actually is even need finer granularity. because we have so many things and they distribute everywhere, indoor, outdoor. Okay, so the idea is this. The message I want to deliver here is locations always matter, and then to handle location, you need some careful thinking and specific information model and encodings. Okay, and then let's move to interoperability. So there's a survey. It said 77% of the IoT expert claim interoperability is the biggest challenge. But what do we mean by interoperability? So first, why does it matter? So the benefits of interoperability. Well, first one, future-proof. If it's interoperable, and that means if you use open standards, and then it tend to consider more cases for the future, and you have more people dedicate into study and make the open standards. So it tend to be accommodate more scenarios and use cases, more future-proof. No vendor lock-in, more choices, which is good if you are building your IoT system. You want choices, right? And you lower expenditure, lower capital expenditure, lower operating expenditure, and lower training cost because you join a big ecosystem, so it's easier to find training material. And finally, I think the most important part is innovation in assembly. If you can make it easy to connect to other systems, and you can create a network effect, and then you can create innovative applications, right? But if everything is a silo, everything is a silo, and how can you create innovative applications? No, you just cannot. So as a result, I think IoT interoperability is not just about the money value, but it's very, very important for the future of the ecosystem. It's in order for IoT to fly, we do need interoperability. So what do we mean by interoperability? I'm wearing my professor hat right now, so look at the definition. So in IEEE definition, it's the ability for two or more systems or components to exchange information and to use the information has been exchanged. So there are two parts. One is exchange, the other one is to use. And actually, think about it. Of all the IoT standards you know, what are the standards they are used for exchange information, and what are the standards they are used for using the information? Actually, lots of the popular IoT standards, they are for exchanging information, but not to using. Okay, so from a very well-known literature, Brody, 1993, so two components X and Y, if they can interoperate, that means if X can send the request R for service to Y, so it sends something to Y, based on mutual understanding of R by X and Y. And then if Y can similarly return mutual understandable response as to X. So it has two parts. One is you have a way to exchange. The second part is you have a way to understand. So both are important. So if you look at this diagram, this is my personal view, but it's very typical. It's a layer diagram. And also on the right-hand side, I list some of the protocols for these each layer. So the OGC mainly is focusing on IoT data interoperability. So we're focusing on the using and understanding part. And we do have a lot of layers they need to focus on how to exchange. I call them network interoperability. So for example, MQTT. MQTT doesn't define a data model. So it's not really about use and understand. It's about exchange. HTTP CoAP. And the IP layer, you have 6LoWPAN, IPv6, IPv4, and you have transit network, local sensor networks like Zigbee, Sigfox, LoRa, Sigfox, and devices, Mbed, Arduino, and so on and so forth. And this layer actually is what we are focusing on in OGC. So data interoperability. And this is really a new area because, as you know, most of popular, if you Google IoT standards, what you get are these layers, but not data interoperability. And so that's the focus. So if we mean a truly interoperable system, a truly interoperable IoT system, we do need to cover all the layers. Just like if you use HTTP, it doesn't mean you are really, for example, if you use HTTP to exchange map tiles, doesn't mean you are really interoperable, right? You do need to follow some ways to describe your map tiles. Describe what do you mean by a map tile, for example. Okay, next slide. Great. Let's look at the other view. Let's say we have an IoT value chain here. So similar to the layer diagram, but from a value chain perspective. So that means if we are building an IoT system, these are the steps we need to go through. The first step, you find a sensor and actuator. The second step, you need something, a gateway, or I call it smart things. So it has a way to connect to network. And third, you need a network. Could be Wi-Fi, Zigbee, Bluetooth, LoRa, Sigfox. And finally, you reach to the cloud. If you want to do analysis, large scale, and aggregate information, you do need to have a central storage or distributed storage. Anyway, reach the cloud. So you do need a device cloud API. So how do you feed your information into the cloud? And you need the fifth component, data analytics. I use the term very loosely, so anything in the cloud is there in that box. And then finally, the sixth step is the application cloud API. So if you want to develop an application, you need that API so that you can develop applications. And so the focus of OGC SensorThings API and Suite is 4, 5, and 6, especially for the 4 and 6. So define the standards, information model encodings, and the way how to exchange the information, the API. So that's 4 and 6. So a very high level, so OGC Vision for Sensor Web is like this. So we have a Sensor Web browser, that's a browser, and I can ask a search engine or catalog, okay, show me the sensors I'm interested. And then the catalog sends you, okay, there are 3 different systems. It can be 3 different servers, and then available. And the browser or the system aggregator, they can put these 3 sources together seamlessly in a one coherent picture. So that's the vision for the OGC Sensor Web Enablement. And yeah, and okay, let's jump into a little bit detail. So we have 2 parts, right? Information model and the interfaces. So this is the core for the OGC Sensor Web Enablement. It's called observation and measurement. It used to describe anything observation. And just to let you know, the observation could be 2 different types of observation. It could be from in-situ sensing. In most of IoT existing APIs, we look at them, they deal with like temperature sensor, right? It's in-situ sensing. But actually, it's also very important to deal with remote sensing. So for example, camera or a drone. And by using ONM, this standard, it can reconcile both in-situ and remote. So same model, we can accommodate both. So this is just the message I want to deliver here. And then this is the concept. Let's say we have observation, but actually you can see on this diagram, or this figure, you can see there are a lot of information. Actually, they are not really observation, but they are critical for you if you really want to use the observation. So the observation, the most important part is the result, right? That like 23 in the at the center of your screen, the red part. However, if you don't know the unit of measurement, it's not very useful. If you don't know the time, not very useful. If you don't know the target of this observation, not very useful. If you don't know the sensor used to collect the observation, and then this observation is not very useful as well because you don't know the quality. So this is just an idea to give you ONM really capture the necessary attributes or properties required if you want to use your observation seriously. Okay, next one. Also, OGC Suite actually is a mature standard. The first version was published 11 years ago in 2005, and lots of organizations are using it. However, it has an issue, which is it's very heavy. It's well, everything together, maybe you need to read 1,000 pages. It's just a lot of complexity there because it works. So actually in OGC, our community, we decide, okay, so if we want to apply OGC Suite into IoT, I think we need to simplify it. But we have a proven working framework. So it's time to simplify it, make it more efficient, so it can be applied to IoT area. So it's proven working and efficient. So that's SensorThings API. I'm going to skip this slide. So that's SensorThings API. Before I jump into details, actually, I just got this yesterday. This is the quote we got, actually, because we did a demo at the Homeland Security 2 weeks ago. And then this is the quote we got. The Undersecretary of Homeland Security, Science and Technology said, impressed by the state of the practical, where various industry sensors can be integrated using open standards, which is the SensorThings API, and remove the stovepipe limitation of one-off technologies. And we are very, very glad. It also shows that SensorThings API is working. Okay, so what is SensorThings API? It's a candidate standard. So right now, actually, OGC is voting to approve the standard, and the vote ends in 5 days. So in 5 days, hopefully, will become an official standard. And actually, I just checked the vote. We just need 2 more votes, and we're done. Okay, and it's part of mature OGC standard, and we provide the following function. First one, data management, so sensing, and analytics, so that's a sensing. And then the part 2 will be tasking, so command and control. And finally, we have an event detection or notification. It's called rules engine. That's the part 3. And right now, it's the part 1 is under the voting process. And so what are we standardizing? So similar diagram here. So we have 2 parts. One is the data model. It's based on ISO OGC OEM. Second part is the RESTful interface, and for accessing sensor data, tasking, and detect events. And the bindings we can use include MQTT, HTTP, and CoAP. So these are the entities of the SensorThings API. And so the central of the API is the data stream. And you can see the relationship between this data stream and other entities. And so we have a thin, and a thin can have 0 to more data streams. So let's say I have a Nest thermostat. So Nest thermostat can have, for example, a temperature sensor data stream and a humidity data stream. And each data stream is collected, collect the data using a sensor. So that's a metadata. And then it's observed some property, like it defined, okay, temperature. What do you mean by temperature? Air temperature or water temperature? Humidity, it's a soil humidity or soil moisture, or it's air humidity. And then each data stream has 0 to more observations. And these are the result of these data streams. So these are the entities. And every box you can see here, you can create, read, update, and delete. So RESTful, right? So you can get, post, patch, and delete each entity. So we use HTVerb to CRUD. So post, create, patch, and delete, for example. So if you're familiar with the RESTful API, and this should be very straightforward for you. So I'm going to do a demo using the playground. So this is an interactive demo. So I'll guide you through the JSONs, the JSON data streams, JSON encodings in order to use this. And for example, first step, you can create a thing, and on your right-hand side, you can see so what is the JSON being sent to the SensorThings API. So let's say, oh, my smart meter, yeah, that's fine. So next one, and then you can choose the location. For example, the location is University of Calgary, CCIT 366, 363. That's where I'm right now. Use my location. And then you can see the API request here. And next, choose a observed property, for example, air temperature. But let's say I want to use water. So water temperature, let's say water temperature of the ocean of my fish tank, for example. But it defines your observed property here using a certain ontology here. And here are the requests sent to the server. Sensor, which is a the device collect the data. So in this case, smart meter. And then the details about data stream, for example, what's your unit of measurement, and so on and so forth. And you have some description over there. And let's go to next. and you can review. So when you click complete, you can start sending these JSONs to the service. So this is a very quick way allow you to learn about SensorThings API, and then so you can go through these, and we have more information and to describe more about SensorThings API. For the time constraints, right? So I'm not going to go through these in details, but I'll just let you know this is a very great resource or allow you to learn the SensorThings API in details. And finally, after we create these metadata, so basically it's the boxes which is relatively to describe these observations. And right now we can send data into it, like 20 degrees, for example. I say 20 degrees, and then it's sent to the service. They say 22, I send it, and this is the request sent to the service, and this is just an example what has been retrieved from the service. Okay, so feel free to try it, and then it's a great resource for you to try. I have some code, example code, but I think for the time constraint, we are not going to do it here, but this is the gist. So you can go there and check it out by yourself. And SensorThings API, not only I just show you how to get the data, to put the data in, right? However, it has analytics, so a lot of query functions there. And then, for example, it consider the paging. So efficiency is very important for IoT. So it has a lot of pagination function. So you can only get the one you want. And then also it has two very interesting functions called expand and select. Basically is try to reduce the number of requests you need to send to the service, because IoT devices are power constrained. You want to reduce the number of connections. And the second one, select, allow you to reduce the data transmitted. So just to let you know, SensorThings API really is designed for IoT devices. And this is a subset of the filter you can do to filter the every entity in the SensorThings API. So you have math functions, add, sub, multiply, and you have the the typical logical operators. But more than that, we have topological operators, we have geospatial operators, and aggregation operators as well. And it's very comprehensive. And then this is based on, actually, we didn't invent by ourselves. This is based on the OASIS OData filters. And I want to show you another demo. And because one great thing about SensorThings API is we have a MQTT extension. So again, efficiency, very important here. So I'm going to show you here. So these are the two links of the JS Fiddle. So we have two JS Fiddle here. So this part on your screen, hopefully you can see it. And this is the subscription. Okay.
We can't actually, Steve. I think you would need to share your world desktop. Can you do that?
Sure. Great. Let me give me 1 second. Can you see it, the screen?
Yeah, that sounds better.
Great. So did you guys see the playground?
Yeah, that we
great.
works.
Great. So we have JS Fiddle. So hopefully you can see it. Great. Glad I've checked. So this is to subscribe, right? So we use Paho, a great library from Eclipse. And then so we subscribe to this topic. And again, because defined by SensorThings, so you know which one you subscribe. And then the data stream ID over here. So the idea is this. So if there are new observation published to this data stream, and we should get the notification here. So this is published, so very similar code by using Paho and send publish there. So let's say I put observation result like 70. I publish it. Supposedly here, I should be able to receive it. Let me do it again. Interesting. Okay. Something's wrong here, but I don't want to go details. But the idea is this. You can easily use MQTT to do pub and sub. But I'm glad I have video to demo. Okay. Let me show a video for the just to let you know that this is really working. Okay, so this is a demo we did for Department of Homeland Security 2 weeks ago. And on your screen, this is an embed device. And then it send data to MQTT, to the SensorThings service. So after it register itself, and then it will show up on the screen. Okay, so you can see on screen, it registers itself, and you start to see the icons popping up. And then the data has been transmitted to the service, and it pushed to the client with MQTT. And similarly, this is the other view, so you can see the latest result. This is one example. And the next one is actually we integrated a smart shirt and the wearable cam, the two different sensing systems. One is in-situ sensing, the other one is remote sensing into SensorThings. So for example, in this case, we register a new smart shirt, so it show up to the system and then start pushing the data to the SensorThings API. So the first responders, right? People can know, okay, what's your vital signs? You can monitor them remotely, so have better protection. And of course, you can have multiple smart shirt deployed and registered. And of course, OGC standard, so the location is handled very, very nicely. And then you can add a widget, so show the real-time heart rate. And finally, actually, I'm going to show you in this system, in SensorThings API, we can easily, seamlessly integrate the camera with the in-situ sensing. So remote sensing and in-situ sensing. The message here is this. It's one API to integrate two very different systems. So that's a great thing about the open standards. And this is the other demo to show you event notification. So basically is you can create a filter. So you only get notification via MQTT when this event happens. So users subscribe to available events, and then you can, so when the sensor reading changes, and then if it's reached some certain threshold, you subscribe to, and they change the value, you get notifications. So this is the other example of SensorThings. Okay, so let me go to SensorThings maturity. So where are we right now? So we are at the adoption very, very end. So adoption vote ends on February 1st, 2016. And we also have a compliance test. So if you have a standard, but you don't have an official compliance test to verify are you really compliant to standard? Actually, the standard is not very useful, right? So we do have a compliance test available. It's very, very critical to evaluate the maturity of a standard, right? And there are at least 4 different server implementation, like sensor ops implementation, just one of them. So choices, right? It's good for everybody. I strongly believe in this open standard. And then it has been tested in OGC Incident Management Information Sharing Pilot in the DHS and IGES. So I know some of you, if you are familiar with OGC standard, you might have these questions. So first one, so is SensorThings API part of OGC suite? Yes. And is SensorThings API compatible with OGC Sensor Observation Services? And the answer is yes. And is the SensorThings API compatible with spatial data infrastructure? The answer is yes. And can I use my existing GIS to connect to SensorThings API? The answer is yes. For example, we have an ArcGIS plugin available, so we can really easily connect to SensorThings. So idea is this, right? It's based on SensorThings API. It's based on a suite of mature standards. So the interoperability actually is pretty good. So it's case study. So we did this, a pilot for DHS. So idea is this. In any incident, there are a lot of information will be collected by IoT devices. However, for decision makers, they need a coherent picture, and sometimes we call it COP, Common Operating Picture. And to enable that, we have to integrate the information from different services, different provider, different organizations, and open standard is very, very important. So I think I just show you some demos about that, so I'm going to skip that. And next step. So for SensorThings API, our next step is after we're done the first part and we are focusing on the part 2, tasking, and the part 3, rules engine. I just show you a demo of the rules engine, but right now it's time for us to write it down into a standard specification. And then we are working hard. We'll bring SensorThings API to ISO JTC1, maybe WG10 on Internet of Things working group. So we want to have it, the SensorThings API, both a OGC standard as well as a ISO standard, and then push to ITUT as well. We really hope SensorThings API can be a truly international standard, not in the geospatial community, but also in a wider IoT community. And actually, OGC standard template is very similar, or the same template like the ISO template. So actually, we envision that it's really save us a lot of time to push it as an ISO standard, and we have done a lot of work on this as well. And to show the other example, actually, we have a very interesting project, and to put the sensors. So we sensor up the Arctic. So put sensors, the ones I show you for the Homeland Security demo, and we're putting into the Arctic. And this is sponsored by Natural Resource Canada, and it will be open source. So if you're interested, stay tuned and let us know if you're interested. Okay, so how to learn more? We have video tutorials in YouTube, and we have developed documentations based on the Slate template. And there's a SensorThings community site, so go there. It's on GitHub, so feel free to leave comments and create the issue, for example. Or you can read our technical blog. And actually, at SensorUp, we have bi-weekly webinars on SensorThings API, so feel free to join. So thank to these partners to support us and to develop the SensorThings API as well as the code. And then
we're back. Thank you, Steve. That was actually really interesting, and
sure.
I can tell that it was really interesting because there's lots of people actually watching us, and all the way from the beginning till the end. So that's really cool. There's actually already a few questions. If you have a question and you didn't ask it yet, feel free to use either the Q&A section in Google Plus, which might not be the easiest thing to find. So you may as well want to tweet using the virtual IoT hashtag, which is what Dave did. There is a question about the way you handle authentication and OAuth sort of authentication. Dave is asking why you didn't use the bearer header from OAuth in your the way you handle authentication in the SensorThings API. So that's a very specific question, actually.
A great question. Actually, we got this question a lot. So the answer is there are two parts. So one is implementation, right? The other is the standard. So the standard is we're focusing on the RESTful API, and we leave the implementation to decide what's the best authentication, access control, security measure they want to take, right? So the other great thing about the open standard. So in this case, the playground, which is a simple demo, right? So we use the one that we are using, and for more we are looking into like more serious ones. For example, we can use something called NIM, National Information Exchange Models, or something like that, or we can use other security measures, and it really depends on your implementation. In SensorUp, we have a couple different ones, depends on the client needs, but the choice is open. It really depends on your requirement.
That makes sense. So yeah, you said you're trying to focus on the REST API. So what does that mean for a constrained device who would like to talk SensorThings? Would you advise to use a protocol like CoAP maybe, and you provide a CoAP binding so as you are more bandwidth efficient maybe?
Yes. So definitely, well, depends. Okay, if you want to have the full SensorThings API, so you can create, read, update, delete all the entities, okay? And you do need to implement CoAP. And then because CoAP is very efficient and it supports the full RESTful. But if you can create other entities like observed property, the location, in advance using HTTP, because you only create once, you don't use a lot of times. And I would encourage you to use MQTT. It's also very efficient, and then it pops up, so you don't to repeatedly to request the service to get the result back, right? You only get when it happens. So two options, for you. Of course, the most efficient way will be you implement both CoAP and MQTT. So we have the best of the two worlds.
And in any case, you need to use JSON as the way to encode the data?
Yes, in this case, it's JSON.
Okay.
Right now, we have only JSON encoding. But however, actually, if you read the API, we have a very compact way to describe, to get the observations. We call data array. So basically, it's a data array in the JSON object. So it's also really very compact encoding, so even more efficient.
Yep. Trying to figure out whether we have other questions. So unless I missed some, I think we're actually running out of questions. Of course, the webinar is going to be recorded, and it is recorded, and people may feel free to use the comment section on YouTube to ask more questions. There was a question actually for you, Steve, as well. Will you be sharing your slides?
Oh yes, I will post the slides.
Okay, so we share the link in the YouTube description and on the Meetup webpage.
Yes.
All right, so I think we will be back in 2 weeks' time on February the 10th, off the top of my head, to talk about Vorto, and there's even more webinars lining up for late February. If you guys have any topics you think would be interesting for the group, feel free to let me know, and we'll be happy to try and figure out a time where you could present. And yeah, Steve, thank you again. I think it was really a very interesting presentation. As I said, all the people that joined us at the beginning, they are still watching us now, so that's really a good sign. And I'm sure you will see many people getting in touch with you and playing with the links you shared to actually get started with SensorThings. So thanks for joining, everyone, and we'll be back in 2 weeks. Bye-bye.